Hello, and welcome to the LNG Unlocked by AI, the podcast that explores the incredible science and engineering that powers our modern world. In this episode, we're diving deep into a topic that's revolutionizing the global energy landscape: liquefied natural gas, or LNG.
Have you ever wondered how we get natural gas from a remote gas field in one corner of the world to a power plant or your home in another? The answer is a fascinating process of chilling it down to a liquid state, making it compact and transportable. Today, we'll journey through the entire LNG process, from the ground to the globe.
So what exactly is LNG? At its core, LNG is natural gas, primarily methane, that has been cooled to a frosty 162 degrees Celsius. At this temperature, it transforms into a liquid, and here's the magic. Its volume shrinks by about 600 times. That's like taking a giant hot air balloon and shrinking it down to the size of a suitcase. This incredible reduction in volume is what makes it possible to transport massive quantities of natural gas across oceans in specialized ships.
But before we can chill the gas, it needs a thorough cleaning. Raw natural gas straight from the earth is a bit like a muddy puddle. It contains all sorts of things we don't want, like water, carbon dioxide, and heavier hydrocarbons called natural gas liquids, or NGLs.
The first step is to purify the gas. Water has to go because it would freeze and clog up the equipment. Carbon dioxide is also removed for the same reason. Then comes a crucial step called fractionation, where the NGLs, that's your propane and butane, are separated out. These NGLs are valuable in their own right and are often sold as LPG, or liquefied petroleum gas.
Once we have our purified natural gas, which is now almost pure methane, it's time for the main event, liquefaction. There are three main ways to do this, each with its own cool-down strategy.
The first is the Cascade process. Imagine a series of refrigerators, each one colder than the last. The Cascade process works in a similar way using three different refrigerants in stages. First, propane cools the gas down a bit. Then, ethylene takes it even colder. Finally, methane finishes the job, bringing the gas all the way down to 162 degrees C.
Next up, we have the mixed refrigerant process. This one is a bit more like a cocktail of cold. Instead of separate stages, it uses a single mixture of refrigerants, methane, ethane, propane, and nitrogen, all working together in one cycle to liquefy the natural gas.
But the most popular method today is a clever combination of the two, called the pre-cooled mixed refrigerant process, or MCR for short. It's the best of both worlds. The natural gas is first pre-cooled, usually with propane, and then it enters the mixed refrigerant cycle for the final deep freeze. This hybrid approach is highly efficient and is the workhorse of the modern LNG industry.
So we've made our LNG, now what? It needs to be stored and transported, and that's a challenge in itself. The LNG is kept in massive, well-insulated, double-walled tanks that look like something out of a sci-fi movie. These tanks are designed to keep the LNG at its super cold temperature, minimizing what's called boil-off, where a small amount of the liquid turns back into gas.
For its journey across the seas, the LNG is loaded onto specialized LNG carriers. These are not your average cargo ships. They are equipped with incredible cryogenic containment systems to keep the LNG safe and cold.
And here's a really cool fact. The small amount of LNG that does boil off during the voyage isn't wasted. It's actually used as fuel for the ship's engines. It's a perfect example of the efficiency and sustainability built into the LNG chain.
From the purification of raw gas to the marvels of liquefaction and the final journey across the ocean, the LNG process is a testament to human ingenuity. It's a vital link in the global energy supply, bringing clean-burning fuel to millions of people around the world.
That's all the time we have for this episode of The Big Chill. Join us next time as we explore another amazing feat of science and engineering. Until then, stay curious.